Okay, you're going to do 2 lessons tonight, so you're going to have a little bit longer of a video to watch, so feel free to kind of pause and break this up. But you will need pencil and paper because there are a lot of examples for you to practice on tonight. We'll begin with section 1.2, exponents and powers. And so it's important to begin by understanding the terminology. So it says an expression like 4 to the 6th power is called a power. And the power has 2 components, the base and the exponent. The big number on the bottom, the 4, is the base, and the floating number up top we call the exponent. So don't confuse the term exponent and powers. The power is the whole construction of both the base and the exponent. And the reason we use powers is so that we don't have to write repeated multiplication all the time. So 4 to the 6th power, for example, is actually a representation of 4 times 4 times 4 times 4 times 4 times 4. And if you were to type that into your calculator, I believe it's going to spit out 4,096. So 4 to the 6th power would be equivalent to 4,096. And when you're typing it into your calculator, you're going to use that caret key on the right-hand side. So 4 caret 6. And you'll see that that key is located right underneath the clear button. So just like you guys memorized times tables when you were in elementary school, if you haven't already, it's a good time to start memorizing some of your powers because it's just going to make your work a lot more fluid. And a good test to see if you've already done this or not is if I am to ask you right now, what do you think 2 to the 6th power is? You either know it or you don't. And if you don't know it lightning quick, it will serve you well to memorize some of these. So 2 to the 6th power is going to be 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64. And so you'll see that I had 6 2's when I was doing my multiplication there. And you just need to know that 2 to the 6th is 64. Okay. Why don't you go ahead and try all of these on your own, see if you can start getting them a little bit more quickly. You can hit pause and then we'll go over them together. Okay, 2 to the 5th, you should have 32. That's 2 times 2 times 2 times 2 times 2. 2 to the 4th is 16. And 2 to the 3rd is 8. 2 times 2 times 2 is 8. And then we all know 2 squared is 4. Okay? When we look at the base 3, 3 squared we know is 9. 3 cubed is 3 times 3 times 3. That's going to be 27. And then 3 to the 4th power, remember, is 3 times 3 times 3 times 3, which is going to be 81. That's a good one to memorize. It's also the same as 9 times 9, because 3 times 3 is 9 and 3 times 3 is 9. All right, 4 squared we know is 16. 4 cubed is going to be 4 times 4 times another 4, which is going to give us 64. And then 5 squared we know is 25. That's on our multiplication tables. 5 cubed is going to be 25 times 5, and that's 125. Okay. Now down here at the bottom, these are just a review of some of the properties you should have learned in middle school. If we look at 4 to the 1st, anything to the 1st power is itself. So 4 to the 1st power is 4. Hopefully you remember what anything to the 0 power is. And this is kind of a definition. This is really important. Anything to the 0 power is 1. So that's something that hopefully you learned back in middle school. Anything. It could be 50 to the 0 power, 2 to the 0 power. It's always going to be 1. All right, good job with that. So that's it for 1.2. Let's move on to 1.3, order of operations. Now, order of operations is going to be a little bit more in-depth, and powers play a role in the order of operations, but we also have other things to worry about as well. I think most of us, when we learned order of operations back in middle school, or probably 4th or 5th grade, probably came across PEMDAS. Please excuse my dear Aunt Sally. And you'll see 6 distinct letters there, 6 distinct things that we kind of do in order. But I don't want you to think of them as 6. I want you to think of them as 4. So we have parentheses as kind of our first phase, exponents as our second phase. After parentheses and exponents, we do multiplication and division together as a family. So these guys are grouped together. And one does not necessarily precede the other. Division could come first. We just read them left to right. So whatever comes in order left to right. Same with addition and subtraction. These are treated as a family. So that's your fourth phase right there, addition and subtraction. Subtraction could come first. We just read them left to right. And then there are all these other individual situations that you need to be prepared for. For example, if we had absolute value, like the absolute value of -7, you'll probably remember that that's 7. Absolute value goes in the parentheses phase. Exponents, that's also radicals. So if you had the square root of 36, which we know is 6, radicals come under the exponents phase. So just remember that as you're solving order of operations problems. Lastly, before we get into some practice here, a fraction bar can act like a grouping symbol. So when you have a complex fraction, you have to be very careful. And basically, it's going to work like this. If this is your fraction bar, everything in the top is assumed to be inside parentheses, and everything in the bottom is assumed to be inside parentheses. And so really you're going to simplify the whole top, simplify the whole bottom, and then at the very end divide. So that's how you'll handle complex fractions. And as for your calculators, we're going to do a lab where you'll get a little bit more proficient in how to type these things in correctly. Computers and calculators understand the order of operations, but you have to tell them by using parentheses carefully exactly what you mean. And we'll practice that as the year goes on. Okay, so let's hop into some examples. Here we're going to evaluate. So I've given you 4 expressions. Remember, expressions, just mathematical stuff floating out there without an equal sign. I've given you 4 expressions I want you to evaluate for x equals 4. And if you want to try these on your own before I go over them, go ahead and hit pause now and do that. All right, well, let's see what's happening here. I asked you if you think A and B are the same. And if you look at A and B, the only major difference is the 3x in B is surrounded by parentheses. And what you want to keep in mind here is that we are actually looking at order of operations problems. Even though these look like small expressions, you're still going to have to follow the order of operations to simplify them correctly. And I should have reminded you, but hopefully you remember by now, anytime you plug in, especially when multiplication is involved, you want to plug in inside parentheses. So let's take a look at this first one. 3x squared. Well, that's going to be 3 times 4 in parentheses squared. I'm plugging that 4 in inside parentheses. And you have a choice to make. You could either do 3 times 4 is 12 or 4 squared is 16. And you have to know which one you're supposed to do. It's not up to you. There's one correct way to do this. And so that comes down to order of operations. Now 3 times 4 would be, multiplying, but 4 squared would be exponents. And the exponents are going to win out on that one every single time. Okay? So you actually do need to do the 4 squared first. This becomes 3 times 16. And then you're allowed to go through your multiplication phase. And 3 times 16 is 48. So hopefully you got 48 for the first one. If you didn't, that's okay. Just try to understand what you did wrong and make amends next time. Now let's take a look at B. Is B going to end up also 48? Well, B's got those parentheses. And so when we're following the order of operations, things are going to turn out a little bit different. Let's plug in that 4. So we got parentheses, 4 for x, the whole thing's inside parentheses, and then squared. Since that whole thing is inside parentheses, I've got to do parentheses first. So I actually do the multiplication here. 3 times 4 is 12. because that's what's inside my parentheses. And now I'm allowed to do my exponents. 12 squared is 144. So notice those parentheses are kind of game changers. They really have a strong impact on how you're going to be simplifying these. All right, let's see how you did with 5x cubed versus quantity 5x cubed. Here we're going to plug in 4 for x. We have to do those exponents first, so you're doing the 4 cubed first. 4 cubed, remember, is 64. So this is just the same as 5 times 64. And 5 times 64 is 320. Now, over here, this is going to produce something different. Inside parentheses, we're going to have 5 times 4. And we actually do the 5 times 4 first. So that gives us 20. And 20 cubed is 20 times 20 times 20. And that's going to be 8,000. So definitely a much bigger number. So order of operations can be confusing, but very, very important. And we're going to add a layer right now. So here you'll see that I've taken away the x. You already know what your numbers you're dealing with are. But now we're going to look at the impact of negative signs with and without parentheses. And if you want to take a stab at this on your own and try first, go for it. You can hit pause and do these. Well, we're going to hop right in. Kind of a similar question here. Do you think A and B actually mean the same thing? Well, these are also order of operations problems. So you are going to have to follow PEMDAS when you think of these. And it might not look like an order of operations problem, but in A, it says negative 4 squared, but it's really saying the opposite of 4 squared. You can think of this as taking the opposite of a number, which is the same as multiplying it by negative 1. So think of this guy as negative 1 times 4 squared. Negative 1 times 4 squared. And if you had to choose there, would you do the multiplication first or the exponent first? And you're definitely going to go for the exponent first because it comes first in the order of operations. So you would be taking the opposite of 16. So negative 1 times 16. And the opposite of 16 is negative 16. So when you are dealing with negatives and you see this kind of construction that does not have parentheses around the number, it's always going to be the opposite of whatever the power would be. So you're going to end up with a negative answer every single time, believe it or not. Over here on B, this is the quantity negative 4 squared. And when you see this kind of construction where the number is protected inside parentheses, what that means is negative 4 times negative 4. Everything inside the parentheses times itself. So negative 4 times negative 4. In that case, this is where we say a negative times a negative is a positive 16. So notice that A and B produce completely different results. That's the impact of those parentheses and when negatives are involved. Okay, come down to C here. C is a lot like letter A. We're taking the opposite of 3 squared. Okay, so that's going to be negative 1 times 3 squared. And we do the exponents first. Negative 1 times 9. And the opposite of 9 is negative 9. Once again, that answer will always be negative. When parentheses are involved, we're going to have to do some replication here. So on letter D, this is negative 3 times negative 3. Negative times a negative is a positive. So does that mean that your answer will always be positive when you have the parentheses? Not necessarily. It's going to depend on this guy, your exponent. If you have an even number of exponents, like you're raising it to the second power, to the fourth power, to the sixth power, it's going to end up positive, assuming that we're dealing with a negative here. If you have an odd number exponent, your answer could end up negative. All right, good job on those. Let's kind of test you a little bit and see if you can do these on your own, applying the knowledge that you just gained. So I do want you to try these on your own. This is pencil and paper stuff for any of the blue examples. So go ahead and copy these down, hit pause, and try them on your own. Okay, let's see how you ended up. We do not have the parentheses, so this is going to be the opposite of 3 cubed. Hopefully you remember that 3 cubed is 27, so the opposite of 27, which is negative 27. Okay, contrast that with negative 3 quantity cubed. Okay, this is going to be negative 3 replicated, so negative 3 times negative 3 times negative 3. Are you going to end up with a negative answer or a positive answer? Well, in this case, a negative times a negative times a negative is a negative, so you get negative 27. You get the same answer as an A, but for very, very different reasons. So you have to be able to reason these out, because sometimes that answer could be the same, sometimes it couldn't. You have to approach them differently because of those parentheses. All right, down on C, you have the opposite of 3 to the 4th. So think of that as negative 1 times 3 to the 4th. That's negative 1 times 81. And the opposite of 81 is negative 81. Okay, let's see what we get over here. We're going to have negative 3 replicated. Negative 3 times negative 3 times negative 3 times negative 3. So quantity negative 3 to the 4th. This is going to produce a positive 81, because a negative times a negative is a positive, times a negative is a negative, times a negative, another negative is a positive. However you want to reason that out. These two make a positive, these two make a positive times a positive is a positive, so 81. Or we could just know that our exponent up here is a even exponent, which is going to produce those positive answers. So hopefully you're approaching these with a little bit more intentionality now. And if you're still confused, completely normal. Remember, you can kind of go back to these notes throughout the chapter, because this is important. All right, let's move on to example 4. You also need to do this one on paper. You can see here we have a pretty serious order of operations deal. So you want to copy this down. Now, I always start off by writing out the order of operations. That way I can kind of cross things off as I go, which I strongly recommend. If you want to do this on your own first, I definitely would explore it on your own first. You can go ahead and hit pause now. And one of the main intents of this video is to show you my expectation for what your work should look like. So let's begin with the parentheses phase. You'll notice that I have absolute value up here on top. That I would include in parentheses. And I also have parentheses here in my denominator. So those are the two things I'm going to attack first. So a lot of this is recopying. So I'm going to recopy my 6 squared minus 10. That asterisk is a multiplication symbol. But I can go ahead and take the absolute value of negative 2. And the absolute value of negative 2 is positive 2. And that's all going to be over 5 minus 1 is 4. So 4 squared. Okay, that would be my parentheses phase. Granted, this whole entire thing up here is inside parentheses. And the whole thing down here is inside parentheses, technically. So I'm concurrently simplifying the top and the bottom. I kind of do them together. All right, let's go into the exponents phase. I do have exponents on top and exponents on bottom, so 6 squared is going to become 36. So 36 minus 10 times 2 over, and 4 squared becomes 16. So no surprises there. And that would be my exponents phase. Then I have multiply and divide. Okay, I only have a multiplication problem here, 10 times 2. So don't do 36 minus 10 is 26. That's a common mistake, but you don't get to subtract. Okay, you cannot do the subtraction first. You have to do this multiplication first instead. Okay, so 10 times 2 is 20. We're talking about 36 minus 20 over 16. That would be my multiply and divide phase. And now I'm allowed to add and subtract. So I do have subtraction here. 36 minus 20 is 16. So 16 over 16. And if you did this on your own and you got to this very good, you do need to simplify it. 16 over 16 is 1. So final answer, this is just a big expression for writing a 1. One thing I want you to notice about the work is it's multi-step. It's 4 or 5 steps. And we kind of have this V taper. So things start off kind of wide, and as we simplify things, they get smaller and smaller and smaller until we've whittled them down to an answer. All right, let's go with one more. You can try this one on your own. Go ahead and copy it down on your paper. And just remember to fully simplify your answer. So go ahead and hit pause now. Try it on your own. Okay, remember I'm going to begin by writing out the order of operations. So please excuse my dear Aunt Sally. The whole top is in parentheses. The bottom is parentheses. I do see some absolute value here and some parentheses there. So I'm going to focus on those guys. So my first step, I'm going to recopy as radical 49 plus 3 cubed minus, and I'm going to go ahead and take the absolute value of 5, which is 5, plus 1. All of this junk over, let's see, 2 plus 3 is 5, so 5 cubed. And I've done my parentheses phase right there. Okay. Moving on to exponents, I do have a radical. That square root of 49 becomes a 7. 3 cubed becomes a 27. Minus 5 plus 1, just recopying. And then 5 cubed, don't get tripped up here. Don't be a guy who writes 15. 5 cubed is 5 times 5 times 5. That's 125. Okay, so this is already starting to simplify. Those are my exponents phase. Okay, now I'm going to look for multiply and divide. But other than the big fraction bar, I don't have any multiplication or division. This is all left up to addition and subtraction here at the very end. Okay, so I need to go left to right. And I'm going to do this in multi-steps. Be very careful. 7 plus 27 is 34. Just one step at a time. Very careful. 34 minus 5 is going to be 29. And then 29 plus 1 is going to be 30. So if you got 30 over 125, that is correct. You will need to simplify your answer. You could divide both of these by 5. And I'm out of room, so I'm going to run over here to the side. And you would get 6 over 25. Final answer. Okay, so that is the expectation for your work. You should have this nice V taper, and tomorrow I'm going to give you much more challenging problems in class, so just be ready for that. And good job with your examples tonight. Make sure you have everything on pencil, everything on paper to turn into me tomorrow. All right, see you in class.